All right, guys. Are there any questions on the assignment from yesterday? So what we're doing today is still working with polynomial functions, but we're going to be doing operations with them. We're going to be doing addition, subtraction, and multiplication. Now, when we add or subtract two polynomial functions, or two polynomial equations, or two polynomial expressions, we can do it vertically and horizontally. If we're going to add or subtract two polynomial equations vertically, we're going to write one over the top of the other. So we're going to write them vertically. So I'm going to start off with the first expression here. So I'm just going to write it out as 3x squared plus 2x squared minus x minus 7. Cubed, thank you. Took me a second. 3x cubed, yes. So we'll write the first one down. And then we'll write the second one right underneath it. And when we write the second one underneath it, we want to put the like terms underneath each other. So the first term we have is x cubed. I'll put it under 3x cubed. The next one we have is minus 10x squared. 10x squared, and then we have what? Plus 8. Now, since we don't have an x term in the second equation, we won't put anything underneath it. We'll just leave a spot. Any questions on how we set this up so far? Now, what are we wanting to do with these two here? We're wanting to add them together. So we'll add them together. Because 3x cubed plus x cubed exactly is 4x cubed. We'll just add our terms. So 3x cubed plus x cubed would be 4x cubed. 2x squared plus negative 10x squared is going to be negative 8x squared. Well, negative x, well, we don't have anything to add to it. It's just going to be negative x. And negative 7 plus 8 would be 1. And that would be it. That's all we have to do with this here. Any questions on this here? Unfortunately, no. Because since we need the variables to stay put, the calculator, when we add or subtract, needs a value for x. So it won't do it. At least these here. There are higher ones that will do it, but they're not allowed on standardized tests. So any questions on how we added those two together vertically? Now we can also do it horizontally. Now when we do this horizontally, really what we're saying is so we can rewrite 9y cubed plus 3y squared minus 2y plus 1 plus negative 5y squared plus y minus 4. So we just write it out like we would normally add or subtract anything together. Now I put the parentheses around it because it's helpful, especially with subtraction, remembering that we do need to distribute the. Okay. Now, at this point here, we can add them together. So we can put our like terms next to each other and add. So the first one we have is 9y cubed. But the other polynomial term does not have any y cubed term, so it's by itself. So we can then say plus 3y squared plus, well, we do have a y squared term over here. It is our negative 5y squared minus 2y plus, well, y plus 1 plus negative 4. And I really just rearranged it to have our like terms next to each other. And now we can combine our like terms, which will still give us 9y cubed And we do have 3y squared plus negative 5y squared, which would be negative 2y squared. We do have like terms with our y, so negative 2y plus y is negative y, and 1 plus negative 4 is minus 3, negative 3. So this right here is our final answer. So if there's one of these that you like doing better than the other, do it. If you like doing these horizontally better than vertically, do them horizontally. If you like it vertically better than horizontal, do them vertical. It doesn't matter which one we do. Any questions on this so far? Do we need to see another example with addition, horizontal or vertical? Okay. Subtraction, vertical. So again, when we subtract vertically, we're going to do almost the same setup as we did for horizontal, or for addition. I'm just going to write out the first polynomial. If there are any gaps, I'm going to leave spaces, but here they're not, because we do have an x cubed, an x squared, an x, and a constant term. Underneath it, we'll write the second one and line them up. So we have 8x cubed minus 3x squared minus 2x plus 9. And again, we're going to be doing what? Subtracting. Now, especially when we subtract, I like putting the subtraction sign under each one, under each spot, not just at the front. And it's really doing this to remind myself that I am subtracting each term. So that when we go and subtract, especially the first set, 2x cubed minus 8x squared, 8x cubed, 2 minus 8 would be 6x cubed. Then we can move on to the next one, 6x squared minus negative 3x squared. Here, the negative and negative would make a positive. So we'd have 6x squared plus 3x squared, which would be plus 9x squared. Then we can move on to the next one, negative x minus negative 2x. Well, here the negative and negative would make a positive. So negative x plus 2x is plus x. And 1 minus 9 is negative 8. And that's all we have here. Any questions on any of this here? We feel comfortable with this here? Let's look at subtraction horizontally. So we subtract horizontally, we'll start with the first. So we're subtracting from 3z squared plus z minus 4 is going to be subtracted from 2z squared plus 3z. So this one here, we do need to be careful of our signs, because the second set of parentheses, we will have to distribute the negative through it, because we're subtracting it. Now the first one will stay 3z squared plus z minus 4. But our other one, we won't have just positive 2z squared anymore. It's now what? Negative. And then we would have minus 3z. Now we could rewrite this with our like terms and say 3z squared minus 2z squared plus z minus 3z minus 4. Or we could have just combined them. 3z squared minus 2z squared is z squared. Z minus 3z is 2z. And then we just have our minus 4. Any questions on any of this here? Now with subtraction, if keeping track of the signs is sometimes difficult or hard to do, you find it challenging, and it can be, I would do the vertical over the horizontal, because it's easier to keep track of the signs and make sure that we have the correct signs. All we have to do is make sure we're lining it up correctly. Any other questions on addition or subtraction, horizontal or vertical? We feel good with both of these here? Well, if we feel good with addition and subtraction, well, what would be next? Multiplication. I don't do, or we're not going to do vertical. We're just going to mainly do this all horizontal. Vertical is a little bit tricky. Well, not so much tricky, it's just an awkward way to do this. Because if we're doing this vertical, well, we're going to set this up as a we can do this one here vertically, because we would set it up like this here, and we are multiplying. And we're going to treat this like we would a normal multiplication problem. So we would say -3, I'll start off with red, -3 times 4 is -12. Then what would we do? -3 times 2x is, and -3 times -x squared would be 3x squared. Now doing normal numbers, what would we do next? We would put a 0 and move over one spot. And we can put plus, because we would do x times 4 is, x times 2x is x squared, and x times -x squared would be -x cubed. And at this point here, we would add the two together, which would give us, well, -x cubed. X cubed, 3x squared plus 2x squared is plus 5x squared. -6x plus 4x is, and -12 plus 0 is, and we get this here. I find this to be a little weird. It still works, it works fine, but it's a funny way to do this. Any questions on how we did this here? Let's do one horizontally, because this is the way that y'all have done before and are used to doing. Because if we do this horizontally, we want to multiply these two together. Well, we're going to do y plus 5 times 3y squared minus 2y plus 2. And really what we're going to do is use our distributive property. First thing we're going to do is multiply through by y. Well, y times 3y squared is 3y cubed. Y times -2y is -2y squared. And y times 2 is plus 2y. Now we're just going to repeat the cycle with 5. 5 times 3y squared is going to be plus 15y squared. 5 times -2y is -10y. And 5 times 2 is plus 10. Any questions on this here? Last but not least, we would what? Combine like terms. Do we have any like terms with 3y cubed? No, so it's just 3y cubed. What about 2y squared? So -2y squared and 15y squared would be like terms. -2 plus 15 is 13, and it would be y squared. We have 2y and -10y, which would be negative 8y plus 10. And that's it. Questions on this here? I prefer doing it horizontally over vertically. A little more fluid. Any questions on this here? Do we need to see another example of multiplication? Okay. Let's look at this because I don't think we really, I have a feeling y'all feel comfortable with this, but we'll go on and look at it anyways. We want to multiply x minus 1 times x plus 4 times x plus 5. Anybody have a guess what we'll do first? Well, we'll multiply two of them together. Now, the two that we multiply together really doesn't matter because I could do these two here first, or I could do these here first. Or if I really want to make this a little bit funky, I can do this one and that one. It really doesn't matter which one we choose. Now, later on in the chapter, we'll talk about this dealing with imaginary solutions, where we'll have x minus I plus 1 and x plus I plus 1, where we have these complex conjugates or the radical conjugates. If we have those, we'll want to do those first. Because if we multiply these together, what will happen is that the I terms will cancel and make it a lot easier to work with. And when we get to that, I will show that again, kind of why we will do that. But here it really doesn't matter. I'll just pick the first two. And we'll do exactly what we just did. We'll distribute the x first. X times x will be x times 4 is plus 4x. Do the same thing with negative 1. Negative 1 times x is negative x. Negative 1 times 4 is. And we get this here. Now the next thing I would do would not be to multiply. Because our first set of parentheses has how many terms? Well, 4, yes? Do we have any like terms in there? Yeah. Might as well combine those. X squared plus 3x minus 4. Doing that really just saves us one set of multiplications we don't have to do. And now, we're going to distribute again. So we'll have x squared times x, which is x cubed. X squared times 5 is plus 5x squared. Move on to 3x. 3x times x is plus 3x squared. And 3x times 5 is plus 15x. And lastly, negative 4. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Any questions on how we got to this here? This one here worked out kind of nice in a sense. Is where are all the like terms positioned? Next to each other. X cubed stays the same. 5x squared plus 3x squared is going to be plus 8x squared. 15x minus 4x is going to be plus. And then we have minus 20. And that's it. Questions on this here? We good with multiplying multiples of these together? Our special patterns that we do have is the sum and difference of perfect squares. Because if I'm multiplying two things that are the sum or difference, where a and b are the exact same, so x plus 3 times x minus 3 is going to end up being a squared minus b squared, or we can just work it out. Our square of a binomial, same thing, squared multiplied by itself, will end up following this pattern here, where it's really the first term squared minus 2 times the two together, or plus 2 times the two together, and we get this here. Now we haven't gotten to cubes, or well, cubes is going to work out in this pattern. A cubed plus 3a squared b plus 3ab squared plus b cubed. And if you notice that the powers of a, 3, 2, 1, 0, and b is 0, 1, 2, 3, they'll kind of do this pattern, the scale. And really we can plug in a and b, the values for it. But you could go on and memorize this one here as well and kind of work with it. Or really the fact that if you plug in negative b in using this one here, you would get the exact same thing. Now this pattern, well, I'm not too worried about special products because we could go on and just multiply them together or use the properties of it. Because here, if we use the properties, we would get 16n squared minus 25. Now if we multiplied, 4n times 4n is squared. 4n times negative 5 is negative 20n. 5 times 4n is n, and 5 times negative 5 is negative. Our two middle terms will. So we end up getting 16n squared minus 25. Now with b, really what we're saying is that I have 9y minus 2 times 9y minus 2, because if it's squared, it's going to be multiplied by itself. Well, 9y times 9y is 81y. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y, and negative 2 times negative 2 is plus 4. And when we combine our like terms, we'd have 81y squared minus 36y plus 4. So we can try to remember the patterns, or we can just multiply them out and get the exact same thing. Any questions on this here? This here would work out to be the exact same thing. Now the last part of your note sheets is this here, the binomial triangle, or Pascal's triangle, the binomial expansion. And it works out that these here are the leading coefficients for each of the numbers as we expand the triangle out. So for a cubic, these here would be the numbers in front. And it works out really interesting if we said x plus 1 cubed. Now the numbers in front of a and b are the same, but looking at this here, x squared plus x cubed plus 3x squared plus 3x plus 1 would actually be the expansion of this. And I'm not just going to throw that out there. We'll actually look at it. You don't have to write this down, because if we multiplied it by itself 3 times, we'll do the first two. X times x would be x squared plus x plus 1. This would be x squared plus 2x plus 1 if we combine the middle two. Now if we do the multiplication again, x squared times x would be x cubed. X squared times 1 is going to be x squared. Then we'll have plus 2x squared plus 2x plus x plus 1 will actually give me x cubed plus 3x squared plus 3x plus 1. So really this here kind of helps as if we're having to multiply a lot of these out altogether. Any questions on this here? Not really. So the 10, 5, or 1, 5, 10, 10, 5, 1. The fifth row. If we multiplied something to the fifth power, well, we could say 6x plus 2 to the fifth. Well, what this is telling me is that the first number, so I'd have 1 times 6x to the fifth plus 5 times 6x to the fourth times 2 plus 10 times 6x to the third times 2 squared plus 10 times 6x squared 5 cubed plus 5 times 6x times 5 to the fourth plus 5 to the fifth. And it's a way to do this a lot faster to where I'm not having to multiply the number by itself 5 times. Because I'm not having to do 6x plus 2 times itself 5 times over to get to the actual answer. Well, since I started this, I might as well finish this. I'm going to need a calculator. The 6 to the fifth is a little bit beyond my memory, because this would be 776x to the fifth. Plus, here we'll have 6 to the fourth. 5 times 2 is 10. Times 6 to the fourth is going to be 12. 960. X to the fourth. Plus 6 cubed, which is 216, times 5 squared, which is 25, times 10 is 54,000, and we would have x cubed. Plus, here we're going to have 6 squared, which is 36, times 5 to the third, times 10, which is 45,000, x squared, plus, well, now we have 5 to the fourth, times 6, times 5, which is 18,750x, plus, well, 5 to the fifth is 3,125. All of that there would be 6x plus 2 to the fifth, which would take a whole lot longer if we tried to do this actually by hand, doing 6x plus 2 times itself 5 times. And that's why this is kind of neat, but we won't ever get that far into it. But that's it for today. Now what we'll be doing tomorrow is division. We'll be starting division tomorrow.